This is John Black, Super Chemist. I'm here to show you or tell you how to make hydroxides. Um, a hydroxide is just a metal and also an OH. And you should think of that OH as part of water. Okay, so it's a positive metal and a negative part of water. And here's an example, calcium hydroxide. You got your positive metal, your negative hydroxide. There's two of them because calcium has a +2 charge. It's in the second uh, vertical row or group of the periodical chart. And I want you to realize, even though this has nothing to do with the video, an acid is just the opposite, because this is a base. A base has the OH, and the acid has the other part of the OH to make water. You can see H2O. Positive metal, negative nonmetal. See how they're opposite? Negative OH part of the water, positive H of the water. And I gave you some examples of some acids. But that's just something extra there. How do you make a hydroxide? Well, if you watch my last video on how to make a carbonate, it's almost the same way. Now this is for all or most hydroxides, but definitely not sodium or potassium. The reason why is because sodium and potassium hydroxide is soluble in water, and most other hydroxides are not, or they're slightly soluble, I should say. So it's easy to make them in a way. And you look down here on these equations here. Basically, you just add some sodium hydroxide to any metal salt that you want to be a hydroxide. And then it will make metal hydroxide and sodium salt. See how they're just switching? The sodium's going to make the salt, and the metal's going to get the hydroxide. They're just switching spots. Let's do these examples. Like here's 2 sodium hydroxides and 1 calcium chloride. Now if you put that in solution, those are both soluble, calcium chloride and sodium hydroxide. So they're all going to be in solution as ions. But when the calcium ion goes in contact with the hydroxide ion, it's insoluble. So they will join together and precipitate out of solution. All right, the sodium chloride will end up being together. They're the only things left. So you're always making your hydroxide, but you're also making a salt, a sodium salt. Like look in here. I use magnesium sulfate this time. That's Epsom salt. So of course I got my magnesium hydroxide, but I got a different sodium salt, a sodium sulfate salt. So if you wanted to make a sodium salt, you know what I mean? Let's say you needed the sulfate, get a, magnesium sulfate. If you need a chloride, calcium chloride. This will precip out, this will stay in solution, and that's how they're separated. I mean, there's going to be a little bit, they are slightly soluble, most of these. So you have your 2 solutions of whatever salt you decided to make, because whatever hydroxide you need. You mix them together, the hydroxide precipitates out, and this new salt stays in solution. Now when we made a carbonate, in the last video when we made it, I told you how to make a carbonate. We would dump, this would be your water, right? And here's your black precip at the bottom. We'd get a big jug or a big container and fill it up with water so that all the soluble stuff can go in there, and then we can siphon it out. But if you recall in that video, there's carbon dioxides in the water because it's in the air, right? And that forms carbonic acid, and that will change your hydroxide into a carbonate. Okay, so you can't really do that if you want to make a hydroxide, a pure hydroxide. Since I just did a video on it, I'm going to talk about calcium hydroxide. This is a kind of good example too, because calcium hydroxide is less soluble in hot water. Most things, the hotter the water is, the more you can get in it, right? not when it comes to calcium hydroxide. Also, it's less soluble in alkaline water, you know, and you're putting sodium hydroxide in there, so I mean, and you're making calcium hydroxide, both alkaline, so that's going to make it less soluble. I want to bring up this too, is carbon dioxide is not soluble in boiling water. And that's what's causing the whole problem, is carbon dioxide in the air or in the water, especially when it's in the water. Really, well, if you heat up the water and you've got CO2, it goes at a fast rate then compared to a solid hydroxide that's just sitting on a table. But it's also less soluble in hot water because it's a gas, so it's the opposite of a solid. You know what I mean? It's less soluble in hot water. So basically, when I made my calcium hydroxide, this is the thing I had to do. I'd heat all my glass, meaning the frit, funnel, anything that I had, I heated it up. Now remember, you have your calcium chloride solution and your sodium hydroxide solution. You're going to mix them together so that your calcium hydroxide precipitates out. Well, I boiled the calcium chloride solution, right? And I added the sodium hydroxide all at once, so that it pretty much was boiling. It's like 95 degrees. Then I mixed them together real quick, and instead of putting them in a big box and waiting for, and siphoning out the water and all that, like I do with a carbonate, I used a vacuum filter. Yeah, because I didn't make out much, because, time is of the essence with this. So I threw it all into the vacuum filter, and I didn't do it, but you should, and I said it in the video. You should wash your hydroxide with boiling water, meaning once you throw it in the vacuum filter, you suck all the water through, right? Now you're going to have to wash it, put some more water in that vacuum filter, because all that precip has salt, like sodium chloride on it or whatever, and you want to get that out of there. So you wash it a couple times with boiling water, but remember, boiling water. That's why you got to heat up all your glass. You don't want to put boiling water into a filter that isn't already a little hot, at least. Throw it in the oven, heat that stuff up until it's like 200 Fahrenheit or something. So then after that, you would take it and you'd have to dry it under a vacuum. Because if you don't have it under a vacuum, or you don't get rid of the CO2 in the air, it's just going to make it into carbonate. And finally, you need to store it in a vessel with no empty space, or else put a vacuum on the container you put it in. But it's a lot easier just to fill the bottle all the way up to the top so there's no air in there. And then that way it should last a long, long time. You think about it, I made that calcium hydroxide. When I was filtering everything, maybe 15 minutes went by, and then the video was over, and I brought my frit funnel downstairs to put some acid in it to clean it. Now, before I finished the video, I threw a little chunk of the hydroxide in some acid to see if it fizzed at all. And it really didn't fizz. So that was a good, telling me that there's no carbonate in it. I brought the funnel downstairs. That must have been another 15 minutes. So a half hour between making it and doing this filter thing. This is what happened. Now when I poured the hydrochloric acid into the frit filter to clean it, there's a little bit of stuff you can't scrape out of the hydroxide, right? But when I put it in there, I could not hear any snap, crackle, pop at all, not even one fizz. Within 10 minutes, the acid still hasn't gone through the frit filter because it's all caked with that hydroxide. Within 10 minutes, I could hear it starting to fizzle, like it's making CO2. So, you know what I mean? Within a half hour, 45 minutes, it's already starting to turn into carbonate, even though it's not even in water. It's just sitting there, you know what I mean? So it's that quick. Anyways, always remember, science is great.